Hello everyone. Today I will talk about my project presentation. First of all, I introduce myself. My name is Navin, son of Ravi. My metric number B0717109444. My supervisor name Inche Muhammad Afiq Amiruddin bin Farnon. My project title is Fluid Flow Analysis of Recycled Cardboard Fertigation System using CFD. As my introduction, in the current situation, the responsible use of water resources is one of the basic challenges of individual face nowadays. Most people realize about this conservation strategy way back in elementary school. And while we will also give some thought to ourselves responsible water consumer, there are still many hidden methods we waste or misuse water each day. So the efficient use of water is become necessary. Hence, water irrigation system is interesting to control the amount of water to plant at needed interval. Other than that, several chemical fertilizers have high acid content, so it's flexible to burn the skin. Finally, the computer fluid dynamics CFD has been used in this system to control the fluid flow phenomena. CFD also allowed for massive reduction of time from the primary layout through the prototype to the complete product. For my problem statement, there are almost everybody on the earth will stay at urbanic area. So they are difficult to plant their garden in their house. So in this concept, they can plant in their house as well as their live in the condominium or other. Other than that, outside food can bring to the house but unhealthy. This is because there are many vegetables are very chemically that sell in the market. So from our self garden, there are not necessary chemical that we use. Waste of time and water. This is because when we use a pipe irrigation system, there's much save our time to watering the plant, and the water also can save by the piping system because the quality of water is direct to the root. Then crop disease. This is because the amount of water is affect the root. Finally, a large number of the thing we discard end up in landfill. This is because the recycled cardboard can use for the plant purpose. In this concept, the old cardboard that we want to throw can save by this method. For my objective, first objective is to design cardboard piping system of water flow in fertigation system. And second, to simulate the flow of water irrigation in pipe for recycled cardboard fertigation. Third is to analyze the pattern of fluid flow for different piping configuration using fluent axis. The scope of study is to develop a closed fertigation system which is usually practiced on the high value crops such as vegetable. From this concept, we can develop a vegetable by a easiest fertigation system. Second is simulate the flow of the fertigation system for different type of pipe, which is exiting product and data. From using ANSYS, the flow of the fertigation system can see early the result. Third is to identify the detailed drawing of structure of pipe by using SolidWorks and the ANSYS development in Fluent ANSYS. The SolidWorks is used to develop the cupboard and the piping system inside the cupboard, and the Fluent ANSYS is used to develop the model and the meshing setup and run the simulation. For literature review, there are flow simulation example. CFD simulation of drag reduction in pipe flow. There are 6 steps. First, identify the general issue. Second is pick up the 3D display programming. which means CFD or NCs. Then third is design, model and generate mesh of the pipeline. Fourth is perform mesh independent studies and approval and check the simulation. Fifth, run the simulation at the different flow. And sixth is classify and analysis and compare the result or outcome. The advantage of the drip irrigation is water application efficiency is high if managed correctly. This is because the pipe system supply the water through straight to the root of the plant. Moisture within the root zone can be maintained at the field capacity. This is because we can limit the volume of the water that we can supply to the plant. Finally, labor cost is less than other irrigation method. Because the irrigation system is very simple and safe, and it is very easier to conduct. Therefore, the labor cost is very low. The advantage of the fertigation used to avoid problems such as volatilization losses, slow dissolving and slow fertilization activation that arise from applying fertilizer onto drying surface soil. This is because the fertilizer is dissolved in water, which means the fertilizer go through the water inside the sand to the plant and save 50 to 70% more fertilizer than conventional fertilizer system, because the fertilizer dissolved in water, so there is no waste of the fertilizer, and then the fertilizer go through straight to the root, reduce the water pollution problem that arise from excessive use of fertilizer in agriculture. This is because when we use normal way, the waters go around many plant. When we want to fertilize the plant, so the water go around a lot of places, so there is a pollution. Type of plant that we can plant in the cupboard fertigation system. There are 4 types of plant: tomatoes, mint, onions and scallion. Other than this, other small plant also we can plant inside the cupboard, depend on the size of the plant. As for methodology, the best software to design cupboard piping system is SolidWorks software, because SolidWorks is the easiest software to design and assembly the basic of 3D part modeling, and it is also very faster and easier and also more efficiency to the product. For the simulation process, the best software is ANSYS, because ANSYS is the most complete software for CFD, computer fluid dynamic. ANSYS CFD goes past subjective outcome to convert precision quantitative forecast of the fluid association and extent of. It is also to determine how a product will function with different specification without building the test product. We can get the result without we build the product. This is a piping system in the cupboard. There are tank above of the pipe, timer, T-joint, and there are 10 outlet, which means 10 drip. Parameter input, name selection, input, output 1, output 2, 3, 4, 5, 6, 7, 8, 9, 10, 10 output and fluid domain. The element size 28.202 default. Quality of meshing thrice. The boundary layer same as the name selection. Layer 5. The growth of layer rate of layer 1.2. The total thickness of boundary layer is 3 mm. The material and the parameter. There are 6 material: tank, micro pipe, timer, T-joint, cupboard and drip imitator. The total volume of the tank is 20,000 cm per cube. which means 20 liter of water, and the pipe diameter is 104 inches, which means 4 mm. In the cupboard size is, the length is 210 cm, the width is 50 cm, and the height is 100 cm, as usual, as we use for the use in our house. The drip size is as used. We can connect to the 1/4 inches pipe. For simulation setup, the gravity for y-axis is negative 9.81. The setting model lamina K epsilon, material fluid H2O, density 1000 kilogram meter cube, temperature 298.15 kelvin, viscosity 1.010 -3. Solution method simple. Solution installation standard installation. Number of iteration 200. For the result, the cupboard design with the piping system. This is the cupboard design. There is the tank, the above of the cupboard, and there inside the piping system. This is the piping design in Fluent ANSYS. There are 4-step modeling. This is the model, and second is the meshing. Third is solution, the inlet and 10 outlet, and finally is result. After solution step, result step including obtain the result like velocity difference at inlet and the outlet velocity result F2 analysis. The best result for the project is K epsilon result for 0.14 velocity. Therefore, the inlet velocity of a K epsilon flow is 0.14 meter per second, and the fluid used is water. The figure shows that the velocity is maximum at the inlet of the T-joint in the pipe. Maximum velocity observed is 0.041695 meter second, and minimum velocity is 0 at the pipe wall. The effect of velocity contour on meshing for 0.14 meter per second velocity. There are 4 type of pipe: straight pipe, elbow, T-joint, and drip. There are maximum velocity when the size of pipe become decrease. This is because when the flow is in maximum velocity when they are moving in the large place to a small place, which means the T-joint, the elbow, and the drip. As conclusion, the SolidWorks software is very helpful to design the cupboard piping system. It is also very easy way to develop the cupboard piping system. And then ANSYS is very useful thing to draw the geometry and simulate the flow, and also finding velocity outlet result of the drip toward the plant. There is also different properties and parameter is done to identify a better result. There are different type of velocity we use in this project, and different type of flow like laminar, V epsilon, and also different configuration was done by adjusting the diameter different and also the height different in both runway. The height of the tank is much lower. For recommendation, in further process we can improve a better system of water in fully autonomous system. You also can using dual tank. As for dual tank, it's more efficiency because of the flow rate divided into the two. If use of one tank for each runway, the inlet flow rate in the pipe inlet can fully utilize at the pipe outlet. The automatic timing system are more efficiency. We change the manual timing system to automatic timing system. This is a 5 reference that I refer. Thank you.